Algebra 2, Law of Sines to solve non-right triangles. You'll definitely need your calculator for this concept, so make sure that you have that, and make sure that you have it in degree mode. Let's get down some definitions of vocabulary. So the first thing is the law of sines. This is a formula to solve non-right triangles. That's a triangle without a right angle. Now the information that you need to know to solve a triangle using the law of sines falls into two different cases. So if you have a triangle and if you know two angles and a side, then you can use this formula, and we'll get to the formula in a little bit, to solve the triangle. So those two cases are if you know two angles and then a side that's not included within those angles. You may remember this from geometry. So this is what we call an angle-angle side situation. Now sketch a triangle and let's label so you can just have an example for yourself of what this might look like. So you might be given a triangle and two angles. So let's say this angle is 33 degrees. This one is 46, and then a side that is not included in between those angles. So as you look around the triangle in order, you have an angle that you know, another angle, and a side. So that's the angle-angle side situation. If you're given that information, then you can go ahead and solve for the other things that you don't know. So that would be the other two sides of the triangle and the other angle. Another situation with two angles and a side would be if that side were included between the two angles, and this is what we call an angle-side-angle case. So it might look something like this, that you're given a triangle and one of the angles is 30 degrees, a side length of 9, and then an angle of 47 degrees. Notice as you go around the triangle in order, you have an angle that you know, and then a side, and then an angle. And then finally you have case number 2, which is if you know two sides and an angle. This is called the side-side angle situation. So it would look something like this. Let's say you know this side of the triangle, which is 9, this one is 6, and then this angle, 52 degrees. So if you know those measurements of a triangle, then you can use this formula called the law of sines to find out, to solve the triangle, which means find out all the other side lengths and angles. Look in your notes section at the actual concept box that has the formula. To solve a triangle with no right angle, you need to know the length of at least one side and any two other parts of the triangle. So the law of sines can be used to solve triangles when two angles and a side are known, or two sides and an angle are known. And we've gone over those cases earlier. So here is the formula, and it's going to look a little different than formulas you've seen before because it has three parts. Now you only use two at a time, so let's say you can pick these two. And then notice that it's in two forms. So this isn't all together one formula, this is two forms of the formula. So you can see the first form has the angles, or the sign of the angles, in the numerators. The second form has the side length, so that's the lowercase letters. So depending on what you're solving for determines which form of the formula that you're going to pick to use. And then notice they are set up as a proportion. So you have units that are the same as the numerators compared to units that are the same as the denominators. So up top we have the sign of the angles, and then in the bottom we have the side lengths in this form of it. And then in the other one it's just switched. Side lengths on top and then angles in the bottom. And again, you only pick two parts to use at a time. So let's go ahead and try one. Our first example is what we call a case 1. So this is when we know two angles and a side. And it can either be the situation of an included or a non-included side. So angle, side, angle, or angle, angle, side. So if you look at the triangle, and this time we have the measurements written out and drawn on a triangle for us, so it's easy for us to see what we've got. we know an angle that's 25 degrees, another angle that's 107, and then a side of 15. So that's angle, angle, side situation. Since we know two angles and a side, we can use the law of sines. So we want to solve the whole triangle, so we're going to find what we don't know. Let's list, and this is the method that I suggest that you use every time you solve a triangle. You start by listing what you don't know. So you need to know angle A. We already know angles B and C, and we need to know side A and side C. And then I just put this in a little box off to the side, and when I have filled everything in, then I know I'm finished with my problem. Now, angle A is easy to find, so I'm going to start there. I can just subtract off the other two angles. So you can do that real quick, and you should get 48 degrees. Now the next thing I'm going to find is side A. I'm just going in alphabetical order. So I'm going to use the formula. If you look back up at your formula box, that's kind of to the right, that form of it, with the side lengths on the top as the numerators. So I'll put side A, and then I'm going to compare it to the sine of angle A. And I know it. I have to write in a number. And then I'm going to use what I was given. So I was given side B, so I'm going to write 15, and then compared to the sine of angle B, 25. Now to get A by itself, we're going to multiply both sides by the sine of 48. So on your calculator, do what's in parentheses first. Take 15 and divide it by the sine of 25, making sure that you're in degree mode. Press enter, then take that times the sine of 48, and we'll round to nearest tenths place, which is 26.4. Now to find side C, we'll just set up the formula in the same way. So we want to know side C, so that'll go in the upper left. We'll compare it to the sine of 107, and then we'll use what we are given, which is side length B, 15, compared to the sine of angle B, which is 25. And again, you'll do the same thing. You're going to multiply both sides by the sine of 107. So on your calculator, first take 15, divide it by the sine of 25, then take that times the sine of 107. And to tenths place, we get 33.9. Now you can always check for reasonableness of your answers in triangles. So the order should be smallest to largest sides will correspond with smallest angle to largest angle. So our smallest side, it looks like, is B. And so 25 should be our smallest angle, and then our next biggest side is A. So angle A is 48, which is the next biggest, and then biggest side is 33, and that corresponds with the biggest angle. Example 2 gives us a triangle here, and we'll just look around the triangle and see what we have. So we have an angle, another angle, and a side. So we have an angle, angle, side situation. So we can use the law of sines to solve. So I'm just going to go ahead and put some labels on my triangle so I know what I'm looking for. So I can call 140 degrees angle A, there, 21 degrees angle B, and then what I don't know is angle C, and then my side across from angle A is side A, and across from angle C is side C. So what I'm looking for to solve this triangle is angle C and side A and side C. So I'll start with my angle again, because I can take 180 and subtract 140 and 21, which will give me 19 degrees. And then I can start with side A. So I'm going to set up my formula. I'm going to take side A and compare it to the sine of angle A. And then I'll look at what I was given. So I was given 100, which I decided is side B. And I'm going to compare that to the sine of angle B. And then you'll just do the same as before. So multiply each side by the sine of 140 degrees. So first divide what's in parentheses, get that answer, then take it times the sine of 140. So rounded to ones place, we get 179. Now we can find side C, setting up an equation using our formula. So what we're looking for, side C compared to not the sine of 21, sorry, the sine of 19. And then we'll compare that to what we were given, which is 100 over the sine of 21. So we'll multiply both sides by the sine of 19. But first, you're going to take 100 and divide it by the sine of 21. Get that answer on your calculator, then take it times the sine of 19. And rounded to ones place, you'll get 91. Now check for reasonableness. So our sides in order are smallest to largest, C and then B and then A. So the angles should go the same way in order. So angle C is the smallest at 19, then B, which is 21, then angle A, which is 140. And then you have solved the triangle. Now we'll work case 2, which is when we know two sides and a non-included angle. So we're just given our measurements listed here, but we can draw a picture. It's not going to be to scale. Try that again. I'll make that a little bit more of an obtuse angle. Okay, so my angle A, I'll call this one A, is 115 degrees. So across from that would be side A. This I'll call angle B, so across from that would be 11. This will be C, and that'll be side C. So you can see what we know is side-side angle. So let's list what we need to find to solve the triangle. So we need to know angle B, angle C, and side C. So let's just go ahead and start with angle B, because we know side B. So since I want to know the angle, I'm going to use the form of the formula that has the sine of the angle up top. So I put the sine of B over the length of side B, and then I'll just compare it to what I was given. Have to put the sine of angle 115 up there and compare that to the side that it matches with, which is 20. So you'll first multiply both sides by 11. So on your calculator, you'll take the sine of 115 and divide it by 20. Press enter, then take it times 11. Now you'll get a decimal like 4984. Leave that in your calculator, okay? And when I put the dot, 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 the ellipse here, that shows that I'm not rounding. Now we need to use our calculator to work backwards and find what the angle is. So this is where you're going to use the inverse sign. So you're going to use your second button, press second, and then sign, and you'll get something on your calculator that looks like what I've written here. And then you want to just pull back that decimal. So on your calculator, if you press second and then the negative, because above the negative you'll see a little A and S. So it's going to pull back the answer that's in your calculator. So it'll take all those decimal places and put them in. And then it's going to give you the angle in degrees, and it'll give you about 30 degrees for angle B. Now to find angle C, we'll just do the easy way. So subtract everything from 180. And let's see, we need to subtract off 115. So that'll leave us with 35. And then side C, we can just set up using our law of sines. So side C now, I'm going to place the side on top, since that's what I'm looking for, compared to the angle that I just found, sine of 35, and then what I was given, so now I have to put the side on top over the sine of the angle. But you'll just use those same steps, where first you'll divide by what's in your parentheses, divide that out, then take it times the sine of 35 and just round it to tenths place. For side C, you'll get 12.7. Now look at number 4. We want to solve the triangle. You may want to pause the video and go ahead and label your triangle like I have, and then write what we're looking for over to the left-hand side. Let's start by solving for angle B. So we'll use the formula and we'll set it up with the sine of B in our upper left. We'll compare that to the length of side B, which is 40, and then we'll set that equal to what we were given. So the sine of 63 compared to 44. Now you'll multiply both sides by 40. So remember, divide your sine of 63 by 44, take it times 40, and then keep that decimal in your calculator. Do the second and then sine, so that's the inverse sine. Pull back your answer by doing second and then your negative button, and it will give you the angle that has that sine. So it'll be 54 degrees. Now let's find our third angle the easy way. We'll subtract from 180. So we'll subtract off 54 and 63, and we get 63 degrees. Now if you're thinking, you'll remember that if angles are the same, then their side lengths are going to be the same. But let's go ahead and set up and use the law of sines to find side C, just to confirm that that's the case. So we'll say side C compared to the sine of 63 equals what we were given, which is 44 compared to the sine of 63. So you'll divide and then multiply each side by the sine of 63, and then, sorry, my dog ran into ones place, you will get 44. Alright, last problem is a real life situation. So a helicopter is hovering between two helicopter pads. And I'm going to draw a picture as I read. The pilot knows that she flew into the air at a 70-degree angle. So here's the helicopter. And then we've got a pad and a pad over here. So an angle and then a distance and another angle. So the pilot flew into the air at 70 degrees. She also knows that the two pads are 50,000 feet apart. She wants to practice her descent so that she comes into land at a 65-degree angle. If she were to start descending now, how many feet would she have to travel in descent, so here, to come in at a 65-degree angle and land on the second pad? Well, now if you look at this triangle we've created, what we know is an angle, a side that's included, and another angle. We can use the law of sines. We only have one measurement to solve for, and that's that distance the helicopter's going to need to fly into that second pad. So we'll take that, what we're looking for, x, and compare it to the, remember this is the law of sine, so we have to do the sine of 70 degrees. We'll compare that to the length that we know, and then this angle. We don't know the angle right now, but we can quickly find it by just subtracting from 180. So take 180, subtract off 70 and 65, and you'll see that this angle is 45 degrees. So we'll compare that to the sine of 45. Then grab your calculator like you've been doing, divide out your measurements in your parentheses, and then take it times the sine of 70. And you'll see that the pilot will need to fly in 66,446 feet approximately. Now do the independent practice problems, and then rather than checking your answers on the video, you're going to take your answers to your instructor for a teacher talk to go over, and also be sure to ask any questions that you have over the material in this concept.